we created something we don't understand, but it works very well and will most probably like be smarter than us at one point. So it's a very weird situations to be in. Yeah.
This is the Assetizer podcast.
How do you trust something that you can't understand? That's one of the fascinating and sometimes terrifying paradoxes of AI. We are building these systems that are becoming increasingly crucial to how we work and how we live. And yet they make decisions for us that neither we nor the machines can always explain. But if we're honest with ourselves, can we humans always explain the decisions we make? This is one of the fascinating questions I get into with my guest on today's podcast. Ursin Brunner is the head of AI at GenTwo. As he explains, something about the complexity of finance makes it particularly suited for AI. We cover a lot of ground in this talk, from the fundamental shifts happening in AI that's making it particularly relevant for finance, to the practical challenges of implementation, to why the financial sector is well positioned for AI transformation. We also tackle some bigger questions. When will AI get smarter than us? Will it take our jobs? Or will it free us from menial tasks and usher in an age of enlightened leisure? Let's have a look. Ursin, you started at GenTwo not too long ago, and you came back here, or you came to here from a real technical background, with an AI background, and you kind of, this is your first foray into finance. So before we get into all of that and why you came to GenTwo, maybe you can tell us a bit about your previous work in AI. You've been in this sector for a while, I think, and what got you interested and what got you started.
Yeah, that's actually, thanks. Yeah, so I mean, I'm like originally a software engineer, like studied software engineering and did this for many years, worked for Silk Engineering, and then also for other companies. And then I think it was 2016, I knew about machine learning in general. You have that in university at one point, but not too much. And then there was this moment where AlphaGo, so this is like this Go board game, which is very complex, more complex than chess and so on.
Yeah, I know.
And then 2016, DeepMind, the Google company, they beat the best player. That was really unexpected. So a lot of people were puzzled, including me. And that was really a bit of a trigger moment. So I thought, like, okay, that's really cool that you can do that. There's a lot of potential. And then I was traveling for half a year and kind of on the side was reading a bit into one of this huge AI Bible. And when I came back, I was like, okay, I want to change into that direction. So that was a bit like the trigger thing. And then I worked for quite a while as a machine learning engineer. And so that's kind of an intersection between software engineering, data engineering, and machine learning, if you want so. So really on a technical side, we did lots of projects for customers, different industries and so. And then I got the position as a team lead and started to become a bit less technical. And I also figured out I like this part, but I also really like the hands-on part where you really dig into it and you understand how stuff works. And now I'm here, and I think there's two reasons to that. First of all, I was working now for a while in consulting, doing a lot of different projects. That's interesting, but what I always struggle a bit is that the duration of projects is often short. And that works better for classical software than for machine learning, because in AI and machine learning, it takes a bit of time until things unfold and you understand really what if it adds the benefit you hope for. You say that at the moment you roll it out and you bring it live, you're only 50% in a project. So the other 50% starts then once you get real feedback from the data, from the live data, and then you retrain the models and you adapt and so on. And this is something that is a bit hard to agree with the consulting schedule, or to come out with the consulting schedule, where you often go in, you do project and you get out.
So people are expecting it to, be done by then and working by then. Exactly. And you're like, no, we have to keep training and keep refining.
Exactly, you have to kind of you keep on going, and that's a lot easier if you work in a product company where you basically think with a longer time horizon. And I think that is one reason, a personal one, but I think the more important one is that I think GenTwo and AI is a very nice match. And I think we will talk maybe about more in detail why that is, but it's just like what we do is complex, it has a lot of variety, and this is often a good case for AI. Because if it's relatively straightforward, streamlined, You can just like build software, and that's a simpler approach to solve a problem. So yeah, I was interested in the challenge, let's say, also using AI at GenTwo.
No, I definitely want to get back to that stuff. But before there, I'm just, because this is not an area that I have any real, certainly no technical expertise in. But I mean, you got involved in machine learning and you started in 2016. Where did you study?
What or where?
What? Or
both? So yeah, exactly. So I really studied data science.
Data science.
And this is always a bit like a confusion. Is it data science? Is it machine learning? Is it AI? Bottom line is all a bit the same, because if you do AI, you need to understand the data part and so on. It's a bit more statistical, a bit more software engineering, but in the end, it's like one big mix. So I studied, I would say, a very applied machine learning field. We did a lot in natural language processing. So this basically was just the time before ChatGPT. The technology was already out. It's like huge transformer models were already out, but still not yet on the level of ChatGPT. So I did 3 papers in that field, which was quite interesting because my professor, he was like leading a EU project, so EU financed project with different universities from all over Europe. So I also continued working in academia for I think 2 more years after my master's, simply because I enjoyed doing that stuff. So
just because when I read about this stuff and the history of this stuff and the people I've talked to, I remember a guy once at an event at UBS, and he was like, "I've been in machine learning for 20 years and nobody cared, and now I'm cool, you know?"
Yeah.
And because my understanding is the technology's been around kind of for a long time, but you just couldn't do much with it until recently.
Exactly, yeah.
Why is that?
Yeah, and also to be fair, I think machine learning is used, as you say, for a long time. Already in before 2000, and then especially from 2000 to 2010, people were using machine learning. They were using other models than these neural networks we use now. Often, for example, they use support vector machines, so different technologies, but it was used already there. What really changed now is since around 2010, 2011 is kind of this whole scaling thing, so that you make huge models and the models become more capable because they cannot just solve a very specific problem, like a narrow domain, but they start to be very useful in a broad domain. Like ChatGPT, you use it for everything. I guess you write some text with it, and I use it
every
for
day.
coding. It's like these models are just tremendously helpful on a broad range, and this is what changed. But as you say, like the technology, I mean, what we build these things on, like the whole neural network thing, that's around since the 50s, 60s.
Right.
Then, to be fair, the architecture we use now has only been around in that exact way since 2017. So it's
that's the transformer thing.
That's
right?
the transformer thing. That there was a famous paper around 2017, which basically came up with a new architecture.
Can you explain it?
Yeah,
no, I've been reading about this Google paper and the transformer. I'm like, okay.
It's actually, if you read the paper, you understand nothing. And neither did I in the first place. But it's really, in the end, what you can think of is like, think of something as flexible as possible. So the architecture needs to not build in or bake in any human bias. You know, all old architectures, they kind of had some human ideas built in or baked into the architecture. And that works always well, like short term, but then long term, these biases are kind of preventing you from getting further. And the transformer is just a very flexible architecture. And if you feed it with enough data and you run enough training on it, so put a lot of compute on it, then you get better results. So that's the simple version. Under the hood, it works with what you call attention. So if you have words, it can pay attention to each word in different ways. But it's just like, you don't need to go too deep, but it needs to be very flexible, very well scalable, let's say like that.
And I read somewhere that it started to really work better when they started to let it be a bit more random, right?
Yes. I mean, that's often, randomness is kind of important.
It's just kind of funny.
Randomness is important. And also often I get asked the question like, yeah, but AI can always just learn or do what we already know, because like it cannot do something new. And then I say always like, actually you solve the problem quite easily with randomness. You just like in a certain amount of times you put in randomness so it can like divert from what we know. So randomness is in the whole field a big advantage.
Okay, cool.
Yeah.
Yeah, just was curious about these things because for an outsider, it's just okay.
Yeah, but I
So-
mean,
but it works.
Let's be fair. Also, for the we don't know why it works. We know we have intuitions, and we can, we can figure out that it works. But how it exactly works under the hood, we don't understand today.
My completely non-technical layman's theory is that our brains are the same. They're kind of random.
Yeah. No, and it's somehow interesting. We have a very rough understanding of our brains, and then we build models with that, neural networks, which are a lot more rough than what we understand of our brains. So it's so trivial, I could explain it to you in 5 minutes. But then if you just scale it up far enough, we get these like emerging capabilities or skills that are really impressive. So we created something we don't understand, but it works very well and will most probably like be smarter than us at one point. So it's a very weird situations to be in. Yeah.
Okay. Yeah, it's changing a lot of stuff, and we'll get back to that later as well when we get to the AGI. All right, so there you are. You have the academic background. You have a practical background doing the consulting. You get into the orbit of GenTwo. Here we are. What made you decide that I want to get into this company? I want to get into the financial services end of things. What was the draw?
Yeah. I mean, first of all, like, strip away from all the technical and product stuff. I think GenTwo is just an interesting company. Like, there's a lot of smart people working here. It's really a pleasure to work with people, and also the size of the company is interesting. The phase the company's in. So this is something that attracted me. But then I think more important is like what we do. We build complex products, and we build like a lot of variety. So I don't know. You want to invest in uranium. But not like in companies mining uranium. You really want to buy uranium. Then we have a product for that. You want to do something with, specific old wine collections, or race horses and so on. So there's just like the variety we do in our products. That was something that I was interested in, because it's quite easy to just invest in Google and Nvidia. But if you want to do more complex stuff, it's not that trivial anymore. So I like the complexity we have in our products. And I think it's a very nice match with AI, because this complexity, as we said before, is hard to model with classical software, because in software you have to do strict decisions, so you cannot just like be too broad. And AI doesn't really have that problem. So if an AI model is trained on a lot of data, it can basically do a lot of different things. It's not really limited to these specific cases. So I think AI and GenTwo, that works very well together, simply because our business model is like offering variety. And that was one of the main factors why I'm here.
Coming over to GenTwo, obviously you're bringing all your experiences, and I guess it probably was, I would imagine, pretty useful having had that consultant's role where you can see a lot of different companies. One thing I'd be curious is, how did you see the sort of practical applications of AI evolving over the 8 years you were doing that before you came here? And where do you see things getting picked up? Where maybe did you see things getting a bit overhyped? How would you say the use of AI has been evolving?
I think how we use AI, and actually we only call it AI for the last 2 years. Before, if you would have called it AI, it would be really wrong. It was machine learning.
ML, yeah.
It still is in a way, but now it's okay to say it again. So for a long time we did machine learning, classic machine learning, which often comes with a lot of work about like gathering data. So before when we started the project, we basically gathered thousands of data points, usually then trained the model for a very specific task. Let's say extraction of a specific text from documents. That was always the task that was interesting. So we would gather a lot of documents and then train a model and then use that. And it was just hard work, to be honest. And then in the last 2 years, we moved away from these very narrow models, more to foundation models like LLMs. And now it's a lot more like just applying these models to the data we have. So let's say document extraction. We have different, let's say, bills. It's always bills or like stuff that companies have a lot of, and you want to extract data in a structured form. That was a big project. Nowadays you just use trained models like, Azure's document intelligence just works out of the box. Maybe you have to fine tune it a bit on your data, but the hard part for a lot of projects fell away in the last 2 years. So that was really interesting to see how it changed, how we could offer projects for a lot lower price also in the end, because it was less hard to do things.
Can I think of that, these foundational models, in a sense like having a generally educated person?
Yes, exactly.
You know what I mean? It's like now this is someone coming in who's maybe got a college degree in a basic thing and can work instead of before where it was so specific. Is that about right?
I would not say a college degree. I would say really like a very standard intern without too much. So it's like it's someone that is somehow capable to make some conclusions, but nothing too far away from what.
But there's this general intelligence.
But you're totally right.
That's kind of there.
Yeah.
Okay.
And that's the big thing we achieved in the last 2 years. It's tremendously helpful because these general purpose models or foundation models, you don't need to train them for each task specifically, and that makes them extremely valuable. And that's the whole hype behind ChatGPT and the NVIDIA stock, if you want. So before it was always you had a specific problem, you had to train a model for it, gather the data for that, and then it could do exactly this. And as soon as you would break out into any direction, it would not be helpful anymore. And what we see actually, now we have it with text, with ChatGPT, this general purpose model. But we also see it in robotics, for example, so that robots, all the fancy walking robots you see in all the videos, they had not too much to do with AI. They used maybe AI to process images and so on, but the whole control was like classical control algorithms. And now we see it also there that foundation models more and more get used to steer the whole robot, to control the whole robot. So we see that in basically everywhere foundation models are taking over.
No, it's fascinating. Okay, so here you are at GenTwo. You're taking over as head of AI. What are the areas in our business that you're looking at, and how do you see AI sort of transforming, contributing to GenTwo's business, and maybe also with an eye towards more general? How's it getting making an impact in financial services generally?
Yeah, let's maybe talk about GenTwo first. What we do, our core business is a lot like interacting with customers. I think there we will use human experts for a long time because it's just the direct communication with the person is something our customers want, and I think it's very important. But what we can help with is the whole automation in the back office, if you want. So because we deal a lot with contracts, with documents in general, so it's a lot of data basically we can automate. And now we are always talking about these agents and agentic and so on. We do that for about a year or two, but I think 2025 will be the year where this also has a greater impact for a lot of companies. So if you go to the financial sector is more or less all in the digital space. There's not too many tasks that cannot be done in a virtual world, and agents will have a tremendous impact on that, because once you basically can automate any process or like any decent complex process, you can automate big parts of the industry we are in. And so why couldn't we do that with ChatGPT in the last 2 years? Simply because these models were not good enough for process automation. Process automation requires you to plan, requires a certain correctness. So if you fail 10% of the time and you have 10 steps, there's a high probability that you fail almost any of the process or all of the process. And so you need reliable models, you need models that can plan, that can reason to a certain degree, and we didn't have that. And now with the latest developments, we see that coming more and more. So I think 225 agents for really like a lot of the process we do in financial institutions are realistic.
Okay, so you're saying automation is one area?
Automation is by far the biggest, I would say.
By far the biggest
area. I mean, you have other things like the interaction with customers. This is more, I would say, retail focused. So if you are a retail bank, most probably you will have an agent or a chatbot already now talking to your customers, but this will come more and more important. maybe to the point that you don't have a classic web page anymore because the customer can just interact with your chatbot, with your agent. That was something that the idea was around for a while, never really worked out because the chatbots of the first generation were just not useful. And now with the latest developments, it gets better and better.
Okay, so we're going to get to the jobs discussion towards the end, but basically you're talking about these agents taking over the roles that are now done by humans in our value chain or in any kind of value chain.
Yeah, and I think there is important to understand you will not replace humans short, midterm completely, not at all, but there's a lot of, I want to say, the rather trivial work that you can automate. So when I think about, like, let's take a due diligence process, which we deal a lot in this company with, so we have to do due diligence on companies, on products, and on person. And in a lot of cases, it's a rather trivial method. But obviously, then, if you find something, you need a skilled human to really understand: is that now a problem for what we plan to do, or not at all? And so the first check, the trivial check, this can be automated. Whereas, like, you will always see, or always, like short, midterm, for sure, you need a professional who really understands the business.
Yeah, look, I see the same thing in my work, which is obviously about content creation, communication, stuff like that. And I've rely on ChatGPT, on Claude, on these models for the past year extensively. And first I thought, okay, I can just pack up and go home. I'm done. Who needs me? Just push the button and it's done. But you really notice that in a lot of ways, if you don't know your subject yourself, the thing can get you into a lot of trouble.
Yeah, and I think that's an important understanding. Like, these things are not smart in a general purpose. They're helpful. At one point, they might be smart or intelligent as we define it, but right now, they're just like helpful for a lot of the standard processes, the trivial stuff. But as soon as you divert into a specific direction, then you need a human to
Now, I remember back in the early days when I started playing with ChatGPT, I asked it to summarize a book that I knew very well. And it summarized chapter 1, fine, chapter 2, fine, chapter 3, fine, exactly. Chapter 4 it got wrong, and chapter 5 it made up. It was a chapter that wasn't even there. I was like, okay, so you come here to GenTwo, and I was interested in where you see the most significant challenges coming to a company like this in trying to implement AI. I'm assuming we weren't really 100% AI ready.
Yeah, but I think AI readiness is a big topic now, because everyone would love to say, we are ready on level 5 for AI. But we are moving so fast right now that AI readiness, what does it even mean? I think it's very important to have the right people in the right positions. So these are people that are willing to move fast, to also throw away things that do not work, and kind of just also intrinsically love the topic. You need to be willing to spend also a certain part of your personal time to keep up with what is happening in this field and figure out, can I apply this to a problem at GenTwo or at work in general. So I think we are ready here at GenTwo, I would say, better than the average bank out there for sure. We have already quite a nice data structure, so we are able to use almost all the data we have to improve AI models. So I think this is a good state we're in. Obviously, the big problem is always to figure out what are you going to solve with AI. And so because you only have limited resources, so where do you make the impact with AI, and where maybe we can help, but it's not first priority.
Data. Let's talk data. So we were on a panel, we had an event here a couple of months ago, and with some other bankers talking about banking and AI, and as I recall, one of the main challenges that certainly banks and probably others are facing in the data area is the fact that data tends to get stuck. It tends to get stuck in silos, and it's hard to, and for an outsider, it's a bit surprising, but apparently it can be hard to get to that data.
I mean, data is the key for AI in general, because what are AI models in the end is just huge mathematical models, and then you train them on data, and the models are always as good as the data is. This is true for all AI, and what is very important for companies like GenTwo is if you're not able to bring in the data you have into these models, then you're basically as good as any other competitor, because what is our differentiating factor or a moat, if you want to say so. It's basically the data we have, which is like owned by GenTwo and like distinguishing us from competitors and giving us a competitive advantage also in that way. So it's essential to access this data and also combine it. So what you do first usually is like identify what are actually the data assets you have in a company, and once you identify them, you figure out how to like fusion them, how to bring them together, how to combine it and clean it so that you can use it then with AI or also just like for simple dashboard stuff like that. So this is really an essential process, and almost all bigger financial institutes have the problem. The data lives in, as you said, silos, and it's really hard to combine it. Sometimes people are also not really willing to do that. So you need to do is you build an overall data architecture, and it's just like often pain because it's a big project and it doesn't show immediate value. Only then you can start building the use case with business value. But yeah, nevertheless, you don't get around. Also, to be fair between us, like all the big cool companies, OpenAI, Google, Anthropic, and so do, they are data experts. And by data experts, I mean like they are able to bring together huge amounts of data and then curate it, clean it, deduplicate it, stuff like that, and train these big models like Claude and ChatGPT and all that. So if you want, so all the cool companies do right now is like building huge data pipelines. So it boils down all of that. Now there's one interesting twist. I heard that recently. It's like you can also combine the data we humans generated as kind of the fossil fuel of AI, because it was essential to get us to the point where we are here. We train all these ChatGPTs and so on the big models we have, on the big data amounts we generated in the last 10, 20 years or 30 years. But what we are now seeing is a bit of a change. So we're getting away from just using the data human created, and we start creating what we call synthetic data. So we use the current version of AI models to generate new data or better data, cleaner data, and then train the next generation.
Yeah, but hang on a second.
So that's kind
I
of
also came across this recently, and I said, wait a minute. So we've trained the thing on the whole internet, and now it's like making up new stuff.
Yeah.
The AI is making up new stuff, and this is going to be better.
Yeah, it's maybe also new stuff is always a bit dangerous to say. I think let's think about math.
Yeah.
When you think about math, what you will often find in the internet is like a question and then an answer. But the whole in between steps, the reasoning chain, if you want, so rarely you find this kind of data.
Yeah.
But this would be essential for a model to understand actually how math works. But for us humans, it's just like we do it in our brains. It's kind of we don't need to write it down in the internet. So what we now generate is synthetic data specifically on reasoning steps for math, but also for in general physics and so on.
Okay.
And then we train models on that.
And you can be sure it's correct.
And that's the essential part. So you generate huge amounts, and then you maybe throw away 99.5%, and the remaining 0.5%, you're sure this is correct, because it's relatively easy for things like code and math and so to verify afterwards if it was correct. So if you write code, you can simply compile it, or write maybe 3 unit tests, and you're sure that it's correct, you know. So it's relatively easy to build verifiers for that.
So we're here in the financial service industry, and as everybody knows, certainly those of us who work here, it's a highly regulated industry.
Yeah.
So one of the challenges in AI is obviously explainability. You mentioned this before a little bit, but you have these great models. They've learned on a lot of data. You ask them a question, a very confident sounding answer comes out, and you have absolutely no clue how the machine got to that answer. So what do you think, or to what extent do you see this as a problem in our industry, and how can we get around it, or how can we deal with this issue?
Yeah, exactly. I think it's important to understand we will not really get around it. And I always bring this example of humans. I mean, when we take a decision, it is often hard for us to explain why we took the decision. So let's say you invested now in a specific stock, or like you're walking along the main station 2 o'clock in the morning and decided to turn around because it's somehow not really okay. I could ask you like what exactly the reason you invested or you turned around, and you would not be able to tell me. You would say like it was kind of a gut feeling. You would say like this Palantir stock, I really had the gut feeling they won't make it. So, and it's a bit the same with AI models. Like as soon as you have powerful models, or powerful thinking things, if you want. So it's hard to really boil it down to one or two inputs and say exactly because of that the decision was taken. So it's something we have to deal with, a certain uncertainty. But there is ways to handle it. I think one way is really a whole field of research. Is what we call explainable AI or mechanistic explainability. So there's a lot of a whole body of research just trying to make these models less black box and better understandable. And that works actually quite well for certain things. So we can, for example, if we have these big models like ChatGPT or Claude, we can basically figure out that there is like an inner circuit or like a subnet in this whole neural network that is activated for specific things. So for example, for if it's talking about someone being afraid. So this is a specific sub part of the whole model, of the AI model, who is just focusing on what is being afraid of. So we can somehow understand a bit how this model works. It's still hard to say now for a decision in the financial field, why was it exactly taken? Because it's just, you cannot say, because of that number in the end, it said buy or sell. It cannot be that simple. One thing that works really well is basically to monitor models very closely once you deploy it. So you basically, you have certain metrics you're gonna always monitor, and as soon as you think the model is going too far away from what you trained it or what you expect, then you basically stop it or review it. So that's what we call monitoring, like data drifts, concept drifts. You want to monitor for that once it's in production, and then you need to retrain. So monitoring is a good thing, explainability is one thing. Then also combination with certain guardrails in classic software is helpful. So for example, they say we need this model because they're super powerful, but we kind of guard them, and if they go too far away from what we know, we kind of immediately loop in a human. So you want to always have the possibility to have a human in the loop.
Okay.
Now, if you go away from financial sector, let's go into healthcare. You would love to have models supporting a radiology expert because it's really a lot of work. Also, there is very important to always have like AI systems just as a second opinion, so you have always a human in the loop who takes the final decision. Then there are certain places you cannot do that. Let's say an agent acting as a stock, where you need to take decisions very fast. I think it's a bit harder, but to be fair, right now with our algorithmic trading bots, we also don't really know what happened. We could explain it, but the combination of the whole system of thousands of these algorithms being deployed in real time is also something we cannot really explain.
So you're saying explainability has been a problem before AI. In a sense, it is.
It is.
Also,
yeah.
Is there a sense maybe, and I just thought of this when you were talking, because you said quite rightly that most humans can't explain why they made a decision. My wife's always asking me, why did you do that? And I don't know, I just
You're
did
sweating.
it. No, but all kidding aside, so if an investment advisor picks a bad stock and you lose money, you feel bad, but it's kind of like, okay, I get the guy or the gal made a mistake.
Yeah.
If the AI does it, it feels different to us, but maybe it shouldn't feel different. It's the same.
I mean, this is a huge topic always with self-driving cars.
Right, exactly.
There you have actually this thing. I mean, we humans do mistakes, and I guess to a certain degree that's okay. We allow it for humans. If you have like an AI running a car, driving a car, you basically, the tolerance for mistakes is a lot smaller. You say one order of magnitude at least, you need to be better than the average human driver, otherwise you will not accept it. So it's a big problem also, who's liable for it in the end. Like now, if an AI picks a stock and it really doesn't do well, who's exactly liable for it? So I think the systems in general, they get only used when they're powerful enough. So as long as they're not quite a bit better than humans or quite a bit more efficient, you anyway don't use them. And if they are a lot better than humans, I think the question for explainability is always less important than actually we want to use them because they're so powerful.
Okay.
But I think, there's different ways. Like explainability research, I think, is a good way. Then having humans close or humans in the loop, not for everything, but for everything that really matters. And then combination with classical software, certain guardrails, and close monitor once it's in production. So I think these are a few of the key topics.
Okay, so you said it. if they are better than humans or when they are better than humans. So that brings us to the, I would say, to the elephant in the room, AGI.
Yeah.
Are we going to get it? And if so, when? Now, I want to know now.
Yeah, exactly. That was always an interesting question. I remember when I started in the field, I think 2016, and that was already the question. When do we going to have like this super AI? Or actually, no, let's first define the term. So AGI means artificial general intelligence. That's not something that is smarter than humans, but it's like on the same level in a broad range of field. Or in a broad field, so not just in specific tasks, but really like in driving a car and like doing a digital process and I don't know, speaking and understanding. So like in a lot of different fields. That's AGI, or the definition. There is not everyone is happy around it about it. It's not like one clear definition. And then you have the other term, the superintelligence, the ASI, which then is kind of a system or a singularity where you have an AI getting smarter on a really fast pace. So these are the two terms that are always talked about. Now let's talk about AGI because that's a bit more realistic to now give a prediction. And if you go back and look at what experts gave in predictions, like the timelines, then it was far more in the future than what we are now. So kind of the predictions came down year by year.
Really?
And that's simply because the advantage or like the improvements and the process was a lot faster than expected. And now people are talking, I don't know, 5 to 15 years is maybe a realistic scale. But there's like experts saying it's going to happen 2025, 26, so it can be really close, this AGI moment. Then again, like what exactly is the definition of an AGI?
Yeah,
so
maybe can I ask, this may sound like a really, really naive question, but how are we going to know we have AGI? Because, I mean, when I talk to my GPT friend,
what is exactly? What is different?
I mean, the Turing test we can forget about. That's been passed a long time ago.
So let's talk a bit about this. I think the word there we often use in the field is benchmarks. So basically, you want to create a benchmark that humans, even the average human, is quite good at, but these models are not good. And we had one of these. It was called the ARC benchmark, quite a simple visual benchmark, where humans would be like on 85-90%, even unskilled 15-year-olds. And AI models would always be bad. It would be under 50%. And that was actually true until December. And now with O3, they just basically like, they crashed it. Now the AI is a lot better than humans. So what you see is that every benchmark we come up with gets saturated faster and faster. And we can also define AGI as basically the moment where we humans are not able to create a benchmark where humans are better than an AI anymore. You know what I mean? Like we are not able to create a test where we humans are better, or like we cannot easily do that. Maybe there's something very specific, you know, like standing on one leg and touching your nose, something like that. But it should not be easy to create a benchmark where humans are better. So maybe that's a good definition of AGI. And that benchmark is very broad. It can also be driving a car, you know, that's part of, it's for sure also benchmark. Yeah. So I think that's the moment where we can say, without moving the goalpost further and further, this is kind of AGI. This is good, as good as a human is in a lot of fields. And then is quite an interesting question, what happens then? Because one of the big factors could be that we use AI models heavily in research. So we basically let AI models on a level of PhD or postdoc in a specific field, we let it research day and night in specific topics, and you will suddenly get a lot of results which we did not expect, because it's just the pace they can research is a lot faster. And if you think about such a process and then you let these models also research in the field of AI, then you kind of get a reinforcing loop where you most probably have faster and faster, better models. And a lot of experts say that's the way how you then get to a singularity where basically intelligence like skyrockets.
Right. So
but now it's science fiction. Now we cannot really know, but that's kind of a plausible way.
So the AI models get better and better. They improve themselves, and we get this self-reinforcing loop. And you said it may be science fiction, but still, science fiction has been dealing with this issue for quite a long time, and usually it's in terms of some sort of catastrophic scenario. So, you know, I feel the need to ask anybody and everybody who is in AI, what are the real risks? What do you see? When do we, when do they take over?
Yeah, and I mean, you will get a lot of different answers. I mean, I'm not telling you now my own answers, but more like what our experts in the field saying. I mean, you have Jeffrey Hinton, one of the big names in AI, who's really what we call an AI doomer. So he thinks there's going to be very negative effects of it. And you have others like Jan LeCun, the head AI at Meta, who says actually he doesn't believe that it's going to be like an existential risk for humanity. I think the outcome could be, as you say, either very good or very negative. One thing I'm personally fearing a bit is like that, I mean, we are right now in a system where we already see that like very few people are profiting a lot more than the rest.
Yeah.
And like usual, in such situations, when you then create something very powerful, this effect is going to be even more improved or extended. So you have like a very small elite who's getting a lot of the cake, and even if the cake is getting a lot bigger, the rest of the population gets not too much. And in a way, you can say that's gonna be the case if you start to automate lots of things. You need to think about like maybe humans are good with coming up with new jobs. Maybe then we have a lot more. Don't want to say influences, but like some other jobs which we couldn't think about like 10 or 20 years ago. So I'm not too worried that people are going to be unemployed or so on a big scale, but it's going to have a huge impact on society. I think it's not to underestimate this.
So maybe we can go from there looking at it on a more positive note, or maybe we can try to end on a bit of a more positive note. No, because looking at the AI future from its good side, what do you see?
Yeah, I think
or what would you like to see?
Yeah, I think, and I think we will see it. I think it's also a bit up to us to steer the whole thing. I think we humans, for all our life, basically, we had to work simply. In the end, it was simply to get food. Now we were a bit away from that, but most of the time we existed, basically, we had to work to get food. That was just the thing. There was no way around. And I think now we are already a bit away from that, but we still need to work. Majority of humans need to work every day. It's just how it is, because we don't have anything doing it for us. And that could be really the difference with AI. We could get to the point where basically we created something that is doing everything necessary to maintain humanity. You know what I mean? Like first it's going to be in the digital world, but then soon we're going to catch up with robotics, and basically also all the jobs in the physical world are experiencing the same. And if we are able to kind of not exploit that too much, or a small part of the population exploit that too much, it will bring like huge benefits for humanity. Like we're going to be in a very different point in 20 years, if you want. So I think, yeah, it's just an incredible thought to be kind of the bootstrap for an intelligence that is greater than us and can basically make us independent from labor, if you want. So from having to work. I'm not saying you don't have to work anymore, you can still do it, but it's up to you. There was an interesting podcast recently with Andrej Karpathy, and he said, think about studying, now you study math, you study all the stuff you did because you need it, you need this skill in your everyday life. Maybe not math, but you know what I mean.
Yeah.
But in the future, we may be studying the same way we go to the gym. Nowadays, who needs the muscles really? But we still do it because it just like is something that is somehow fulfilling, and it's going to be the same with studying, with acknowledging, or like getting a knowledge in the future. Yeah. And it's somehow a nice thought, I think. Like we don't have to, but we can still. Like we can still do something.
I thought about that once myself with languages, because I like to learn languages.
Yeah, exactly.
And nowadays, there's really no reason
it's not to
learn a language, except when if you do it yourself, you have it in you, and it's a different experience.
I think if you want, so that's just one of the fields where it already happened, no? And it will happen in a lot more fields.
One last question, bringing it back to our business and the financial services. So for other companies like GenTwo or banks, or maybe even asset managers who make up a large part of our clientele, who are getting started on their AI journey, what would you recommend?
Yeah, I think it's very important to get the right people in for that. People who are, as I said before, willing to move relatively fast, who are really interested in the thing. And then also just like to try things out, because when you're in a trajectory that is very steep, you cannot build big parts because tomorrow they're obsolete. But if you have a small team, skilled people that can move fast, you can profit a lot. And also not to fear it, just like to play around with it and figure out where it really helps. I think that's the essential part.
Cool.
So as most of the time, it is all like getting the right people in to do it.
Well, I'm sure glad we have you.
Thanks a lot.
That we got the right person in here, and that was a really great talk. Thanks a lot, man.
Thanks a lot, man.
Appreciate it. Bye.